Hello everyone, welcome back to Shikara Academy. So in today's video, we are going to discuss the awakening of Hayli Gubbi, which is a volcano in Ethiopia region, which has erupted after 12,000 years. So it went on into the dormant stage between the Pleistocene and Holocene epoch. And after that time, it was still dormant. It was not extinct. We have three classifications of volcanoes: active volcanoes, dormant volcanoes, and extinct volcanoes. Extinct volcanoes are those where the magma chamber is gone, there is no chance of it erupting again. Whereas dormant volcanoes are those volcanoes where the magma chamber is still present, but it has not been erupted for a very long time. That means it is in a dormant stage. Now, this Hayali Gubbi volcano came out of its dormant stage and erupted by after 12,000 years. So let us discuss where does this happen, what is the location, and why this volcano erupted, what are the causes for which these volcanoes erupt, and what type of landforms these volcanoes form, what type of magma is present in this Hayali Gubbi volcano. So all this is very important for your UPSC and also state PSC examinations. So let us begin. Before going into the topic, I brought you a very good news where Shikara IAS Academy is starting Group 1, Group 2 and Group 1, Group 2 combined batches from December 4th. From December 4th, Group 1, Group 2 and combined batches are being started. So in these courses, you will get all live classes, as well as if you are not able to listen to the live classes, you are on some work or something, you will get all recorded classes and they will be available till the validity of your course. And you will get all subjects comprehensively will be covered. Telangana related subjects, the Indian subjects, all the subjects will be comprehensively covered. Each and every topic will be discussed, and you will be given proper study materials and handouts after each class. Then you will also get subject wise tests, sectional tests. Then you will also have full length tests according to your prelims examination. Then you also have mains answer writing classes, essay practice classes. You will also get mains answer writing test series. For essay, you will get test series and full length test series mimicking the examination pattern. So this is a comprehensive course where you also get Telangana and Indian current affairs comprehensively. So everything will be done at one place. So this is a one-stop solution for you. One-stop solution for you. So this batch is starting from 4th December, and group 2 batches and group 1 and 2 combined batch, all of them are starting on December 4th. So hurry up, register with the link below and start your journey with Shikara IAS Academy. And Shikara IAS Academy is also having mentorship batches where those people who are studying on their own, most of the time they lack guidance, because of which they either they do not study properly, or they use wrong resources, or they spend too much time on some topics and do not spend time on other topics. So there are many mistakes which people do during their preparation. To avoid their mistakes, you will have a mentor who are the faculty members of Shikara Academy. They will be your mentors. They will have one-on-one sessions with you regularly every week. Then Deepika ma'am herself will have a session with you one-on-one every month, and you will also get strategy sessions for you, answer writing sessions for you. Then you will get comprehensive coverage of current affairs, and you will also receive all the tests, subject-wise tests and full-length tests, more than 100-150 tests you will receive. So this is all done in this mentorship batch at a very low price. So this is also starting from 1st December, and all of you, I welcome you all to join these courses and start your journey with Shikara IAS Academy. So now for the topic which you all been waiting, we are going to the Hayali Gubbi volcanic eruption which happened on November 23, 2025. This Hayli Gubbi volcano erupted in the region of Ethiopia, which is in South African continent. So this has erupted approximately after 12,000 years. So we had Pleistocene epoch, then then we have Holocene epoch. So in between, somewhere over here, this volcano became dormant. So dormancy started at the end of Pleistocene, and now in 2025 it has erupted again. Now the eruption of this Hayli Gubbi ended a dormancy period spanning the entire Holocene epoch. Entire Holocene epoch has passed away. At the end of Pleistocene, this erupted. Now after Pleistocene, the complete Holocene epoch, this was dormant stage. Now this again erupted. So the eruption was explosive, sending very high ash plumes, 14 to 15 kilometer ash plumes in the atmosphere it has sent. This high altitude cloud disrupted the aviation routes across the Red Sea. So here we have Africa. In this region we have Ethiopia. So over here we have Ethiopia. Here we have this part is called the Red Sea. So over the Red Sea, the trade routes, aviation routes got disturbed. So across Red Sea, Yemen, Oman, and parts of Western India, this impact of this volcano has been seen. So the sudden release of volcanic ash and gases like sulfur dioxide, etc., they pose significant challenges like aviation hazards. The fine ash particles can melt inside jet engines, causing failure of the jet engines, because of which flights were diverted across the Middle East. Then the impact on climate change. While the sulfur dioxide injection can reflect the sunlight, it can temporarily cause cooling, but it will on the long run cause global warming. Then on health, it will lead to respiratory risks in the regions near to that, and also it will also impact the agriculture. This ash, etc., can cover the leaves and make an issue for the perspiration, etc. So this region, this is Africa, and this is the Great Rift Valley. So Ethiopia is over here. This is Ethiopia. So over here, this volcano has erupted in the Ethiopian region. So Hayli Gubbi is located a far region of Ethiopia, part of the East African Rift System. This is the East African Rift System. Now this is at the triple junction where Arabian plate, Nubian plate, and Somali tectonic plates meet and pull apart. So there is divergent and convergent plate boundaries over here. Because of the divergent plate boundaries, this impact has been seen. Then there is Danakil Depression, one of the hottest and lowest places on earth is present over here, which is because of the rift process, the process where the plates are dividing, because of which there is the hot magma is coming up, because of which there is a hottest place which is called Danakil Depression. This is also in this region. Then there is crustal thinning. The continental crust here is extremely thin because of movement of these plates, allowing magma to rise easily to the surface. When two plates diverge from each other, there is a fault which is being created here. So there is space getting created, because of which the magma can easily erupt out. Now we have the mechanism is because of the divergent plate boundaries, as we have discussed. The Ethiopian rift is a classical example of divergent plate boundaries on land. Usually we see divergent plate boundaries in the oceans. You have mid-Atlantic Ocean ridge, mid-Atlantic ridge, which is continuously in. It's a continuous ridge which is throughout the Atlantic Ocean. It is a S-shaped ridge because there is divergent plate boundary. On land, if you want to see a divergent plate boundary, you can see over here in this region. So this is an example of divergent plate boundary on the land. Because of convectional currents, if you have studied the convectional current theory, in the plate tectonics we study seafloor spread theory, then we study the convectional current theory, we study the plate tectonics theory. All these theories are present when we study the world geography, the movement of continents and landforms. We study these theories. So in this theory there is a convectional current theory. Inside our earth we have a layer called asthenosphere. So if we look at the earth's interior structure, we have crust of earth, then we have mantle, then we have core. The mantle, the upper part of mantle is called upper mantle. Then here we have asthenosphere, where the rock is in semi-molten or fluid. The rock is molten. Then this is lower mantle, which is solid. Then this is outer core, which is liquid, and we have inner core, which is solid. So this whole region is mantle. But the upper mantle and crust of the earth, both of them are called lithosphere. Below this lithosphere, we have this molten material. So this lithosphere is not continuous, it is broken into many plates. So these plates are freely floating on the asthenosphere. So we have different plates. And inside we have asthenosphere. Asthenosphere is hot molten liquid magma which is moving in the convectional current in this way. The heat is transferred in this way. So if you look at this border, the convectional currents are moving in this direction. So they are pulling the above plates in this direction. Whereas if you look over here, the plates are coming towards each other. The currents are coming towards each other, because of which they are pulling these plates towards each other. Because of which divergent and convergent plate boundaries form. Now this Ethiopian region, the Rift Valley in the Africa, is a divergent plate boundary. The Ethiopian rift is classical example of divergent plate boundary because of the convectional current which is present in the mantle or the asthenosphere region, because of which the central block drops down from the Rift Valley. We have Horst Graben type of structures. So imagine this part of the plate, it is getting subducted. These parts are getting rising. So these are called Horst and these are called Graben. So Rift Valley is in the Graben region. So it is subducting inside, it is going inside, because of which it also leads to the very hot nature of that region. Hottest place on earth is there, and it also leads to volcanic eruptions, decompression. When the plate is going inside, the plate rock material will also get molted, and the molten material will increase, which will result in eruption of volcanoes. Melting occurs at the crust, and the crust will thin, because of which basaltic magma will develop, forming shield volcanoes like Hayli Gubbi. So we have different types of volcanoes. We have shield volcanoes, we have stratovolcanoes, we have cinder cones. Shield volcanoes are those volcanoes where the lava which is erupting is highly viscous, or it is very less viscous, low viscosity. For example, you take water and honey. Water will be very low viscous, so if you pour the water, it will flow away. Whereas you pour honey, it will not flow that fast. So these volcanoes are having low viscosity, so that the lava will flow with speed and for distances. So the volcanic structures, mountains which are formed are like this. They are not tall like this. They are like shields. Hence they are called shield volcano because of the less viscosity of the lava. The volcanoes are forming like this because the magma is flowing to big distances. Whereas in case of stratovolcanoes, the lava or magma is acidic and also it is highly viscous, thick lava. So it will slowly flow and at some distance only it will get solidified, because of which the height of the mountains will increase. So in case of stratovolcanoes, these are highly explosive. The shield volcanoes are not that much explosive. Only when there is some water going inside the vent, or there is solidification, or there is some obstruction inside the vent, then only there can be explosion in shield volcano. Otherwise they will not be explosive. Whereas stratovolcanoes are highly explosive and they are tall like Mount Fuji, and the lava is acidic. Whereas in the shield volcanoes, the lava is basic or basaltic lava, or the lava is basaltic. Then we also have cinder cones, which are small steep mounds of loose pyroclastic material. Small cones which are like this, which are called cinder cones. So our Hayli Gubbi is a shield volcano, but because of the very long time it did not erupt, the vent got blocked, because of which there was explosive eruption. Otherwise, shield volcanoes which regularly erupt, they are not explosive. So that you have to know. So I have given some additional information here about the volcanic landforms. So volcanoes, we have different types of landforms. Like imagine these are all intrusive, means these are the landforms which are forming inside the surface of earth. So inside the, below the layer of the crust, below the earth, they are forming. So if this is the surface of the earth, they are not above the surface, they are below. On the above surface we have volcanic cones, the mountains or shield volcanoes, etc. These cones are above the earth's surface, because of which they are called extrusive. Intrusive means within the earth's surface. Imagine here there is a magma chamber and lava is erupting up, it is going to sides also because of some spaces, and here it has solidified and there are some landforms formed, structures formed. These structures are called intrusive volcanic landforms. So if a big chamber of magma is solidifying, this is called batholith. This is called batholith. Big chamber, if it got solidified, it is called batholith. Then we have locholith. Locholith means a dome shaped. Inside there only there is batholith over here, and within this chamber only there is some other region where the magma is solidifying in the dome shaped inside the earth only. This is solidified now. So this is called laccolith. Now we also have sills, dikes. Sills means horizontally. We have this type of structures are called sills. Here if you can see sills over here. Dikes means vertically they are solidifying. These are dikes. So these are sills. These are dikes, etc. These are all volcanic landforms which are intrusive volcanic landforms. We also have some other intrusive landforms like phacoliths, which are wavy structures inside the earth only, they are solidifying. So this type of structures are also present over here. So these are all intrusive structures. So what is the difference between lava and magma? We have been using the word magma, lava. When the molten material is present inside the earth, beneath earth's surface, it is called magma. When it comes outside the earth, on the earth's surface, it is called lava. Similarly, we call when the meteors are present in the space, they are called meteoroid. When it is in the atmosphere of earth, it is called meteor. When it is reaches the earth's surface, it is called meteorite. So similar to that, based on the location of it, the name is changing. So when this hot molten rock material is present beneath Earth's surface, it is called magma. When it is present, when it comes out on the surface of the earth, it is called lava. So The gas content will be very high in the magma. The gases are dissolved inside this magma because of the high pressure. In lava, the gases are less because they escape when the magma is erupting into the atmosphere. Temperatures are extremely hot in magma, whereas slightly cooler because as soon as they come above, they will get solidified and they will reach the normal temperature of their surroundings. Resulting rocks can when the magma erupts, the resulting rocks are intrusive igneous rocks like granite. When the magma cools down inside the earth, it is called intrusive igneous rocks. So when rock is directly formed by solidification of magma or lava, it is called igneous rock. The rocks which are directly formed from lava or magma are called igneous rocks. When these igneous rocks are directly forming inside the earth, they are called intrusive igneous. When they are forming on the surface of the earth, they are called extrusive igneous rocks. So intrusive igneous rock, we have rocks like granite. When it comes out and solidifies, we have rocks in igneous rocks like basalt, obsidian, etc. All these I have discussed in your geography series when I discussed the volcanoes. So this is your Hayli Gubbi, which has erupted after 12,000 years. This is in news, and I have discussed it comprehensively so that it is easy for your examinations also. Right? I have given a UPSC mains question. Discuss the geophysical characteristics of East African rift system, how the plate boundaries are diverging, and the only diverging boundary on land which we can see. So why is it happening? All those characteristics we have to discuss. Then how does the recent eruption of Hayli Gubbi highlight the active tectonic process in the region? So it is linked to that. We have to discuss that. 150 words, 10 marks, write in 10 minutes. So if you have any questions, please mention in the comments so that I will get back to you. Thank you all. We'll meet again in the next video.